Unit 5, trig word problems and inverse trig. These trig word problems are some I think we did in Algebra 2 a little bit at the end of the year, and then we definitely did them in geometry last year. So level 1s, they're not too bad. We will get to where we talk about an angle of elevation and an angle of depression. But the first one is just a basic right triangle. So it says an electrician leans an extension ladder against the outside wall of a house so that it reaches an electric box 28 feet up. So it's a vertical distance. The ladder makes an angle of 71 degrees with the ground. Find the length of the ladder. Round your answer to the nearest hundredth of a foot if necessary. So I'm picturing this ladder leaning like this against a building, and then this would be the ground. So there's my right triangle. I see that the electric box is 28 feet up. So it'd be like up here, right? And then the ladder's making an angle of 71 degrees with the ground. So here's the ladder, here's the ground. So this is my angle. Find the length of the ladder. If it was asking how far is the base of the ladder from the building, that would be finding this horizontal leg, but it's actually wanting the hypotenuse because the ladder is the leaning part in this problem. And so then I look at my angle and I see that I have the opposite side and I have the hypotenuse I'm trying to find. So remember our SOHCAHTOA. Those are our three trig functions we use. So we'll have opposite over hypotenuse, which would be sine. It's always sine of your angle equals your ratio of the opposite leg to the hypotenuse. And so if I'm trying to solve for x, I would have to multiply by x to get it out of the denominator. So it's x times the sine of 71 equals 28. And then sine of 71 is actually a value you'll get on your calculator, so we want to divide that away from x. Okay, well, you want to make sure you're in the right mode. Since we're dealing with degrees and not pi and radians, we want to go to mode. And I am already in degree. Make sure you are not in radian, you want to be in degree mode, and just hit enter, and then you can second quit. All right, so we're taking 28 divided by sine of 71. It's the nearest hundredth, so that'd be 29.61 feet. That's the length of the ladder. All right, number 2. Kaj is flying a kite, holding her hands a distance of 3.5 feet above the ground, and then she's letting all the kite string play out. That just means all the string out. She measures the angle of elevation from her hand to the kite to be 33 degrees. If the string from the kite to her hand is 75 feet long, how many feet is the kite above the ground? Okay, so we've got this girl here, Kaj, flying a kite. This is the kite's string, which is going to be our hypotenuse. This would be her horizontal, and then we'll make our right triangle right here. They're telling me that her hands are already 3.5 feet above the ground. So I didn't draw her legs longer. 3.5 feet would be this right here, from like here to here. Okay, and then they say that the angle of elevation from her hand to the kite is up here. No, my drawing is not good. The kite's up here, so this angle of elevation would be right here, from a horizontal looking up to something. And then the string from the kite to her hand is 75 feet. That's our hypotenuse in this problem. How many feet is a kite above the ground? All we can find is this distance here with our triangle, but when they're wanting it all the way to the ground, we'll have to add our x to the 3.5. Okay, so from this angle, we don't know the opposite, but we want to find it, and the hypotenuse. That would be another sine problem. Sine of 33 equals x over 75. This one's easier to solve. You just have to multiply by the denominator, 75. So 75 times sine of 33 gets us 40.5 0.85 if I round. But remember, we're going to have to add to that this 3.5 to get the total distance off the ground, which would be 44.35 feet. Number 3. From a hot air balloon, Violet measures a 24-degree angle of depression to a landmark that's 806 feet away, measuring horizontally. What's the balloon's vertical distance above the ground? Round to the nearest tenth. Make sure you're always reading these directions because I like to change the rounding up on you. So somebody's up high in a hot air balloon. You've learned my drawing is not very good. That's my hot air balloon. And then we've got somebody looking down to a landmark. Let's talk about this angle of depression. Angle of depression is always some horizontal line looking down. So that would be right here is 24 degrees. Okay, but I like to go ahead and make my triangle be like this. So I'm hoping you remember from geometry that when we have a set of parallel lines, which would be this guy and this one, and we have what's called a transversal, something that goes through those two lines, we can have these angle relationships, and the one you need to know for this is alternate interior angles. That makes this also be 24 degrees. See how they're alternate on opposite sides of the transversal inside the parallels? So I put my angle actually inside the triangle here. And then what else do we know? It's 806 feet away, measuring horizontally. So from where the hot air balloon is to where the landmark is, this horizontal distance is 806. And we're wanting to know the vertical distance above the ground. So there's no adding or anything this time. From this angle, we're trying to find the opposite leg. And we know the adjacent, that would be TOA, tangent, of 24 equals opposite over adjacent multiplied by 806. And I get 358.9 feet.